So I hope everybody uh, got a chance to work on the assignment. I'll be posting the solution after class. And today we are gonna start with completing the lab exercise that we started on Monday. So please, if you have your model with you, please open the model and let's continue and finalize the development of this example. So let me just show you what we are trying to model one more time. This is a system with two different part types that are split into two different machines, drill 1 and drill 2. 60% or part type A are 60% of the parts. They go to drill number 1. And then 40% of the parts which are part type B are going to drill number 2. And they're having different processing times, and these are not identical machines. And we are interested in collecting data for 24 hours about these 5 performance metrics: cycle time for all parts, cycle time for part type A, cycle time for part type B, the utilization of machine 1, and the average number of parts completed. So on Monday, we started building the experimental frame, and I think we completed that part. But we ran out of time when we were working on building the model. So we got into creation of entities with an exponential 4.4. That's the average rate between intervals. Then we assign a couple of attributes, part type and the arrival time for each entity. And then we split it based on the attribute part type. So if you were part type 1, you go to drill 1, which is the first branch. And we have the Q, the C is delay release for that first drill. And I think that's the last part that we did last time. So today we're gonna start from here. We're gonna work on the second machine, which is gonna be similar to drill 1. The only difference will be in the names used to denote the queue and obviously the machine that you're gonna seize. And also there's gonna be a difference in terms of the probability distribution for the processing times. So our queue, so we already defined the names for the queue. This is drill 2 queue. So I'm going to assign that name to the queue for drill number 2. And next, we need to seize a resource. So the resource that we are going to seize is drill 2. And we only need 1 unit. So we seize this machine only with 1 unit. And then click OK. And the next thing is to state the probability distribution for the processing time. So again, here you can use the build expression for random distribution. And then this is a triangular with the following parameters: 3, 4, 5. So the minimum value is 3, the most likely value is 4, and the maximum value is 5. Any questions about this? Okay. So that distribution is now linked to the second machine. And then once the processing time is completed, we're going to release that drill 2. So we add drill number 2 to this release block, and that completes the logic for the second drill. So from this point forward, what we're going to do is collect data. right? We are gonna collect information that will help us compute these 5 performance metrics. So we are gonna use a combination of blocks, the tallies, the count blocks, and then finally a dispose block. So let's start with counting, right? So let's go to the blocks here and find the count. And we are going to use the connect option to connect both release blocks to this counter, because we are interested in counting all the parts that are completed. So we connect both of those release blocks to the counter block. And then we find the counter ID that we already defined, which is parts completed. So that's why we go through the process of defining all these or declaring all these items before we build our model. That kind of simplifies the process of building the model. So parts completed, and then our counter increment is 1. We're gonna count. Every time one part is completed, we add 1. So that's for the parts completed. And then there are two, actually 3 tallies for the cycle times that we need to use. So what I'm going to do first is I'm going to collect the information needed for all parts, okay? So let's start with that one. So I'm gonna find a tally. I'm going to connect that here. What is the tally ID? Well, for all parts, I'm gonna be using CT. So that's the name. And then the value, here's where you need to remember. How do you find the difference between the time where the part is about to leave the system and the time where the part arrives into the system, and you have to find the difference, right? So we are gonna type an equation here that is very simple. If you remember, in order to find the time right now, we have a variable that is called T now. So I'm gonna use that variable, T now. And that's a variable that is defined by the software. And I'm going to subtract that attribute that was assigned to the part at the beginning of the simulation. So that name is arrival time. Right, so once the part goes through this tally, the software is going to look at the time right now, and it's going to subtract the time of the arrival for that part, and it's going to save that number into the tally. And every time a part goes through this block, that's what's going to happen. T now minus the arrival time. Okay. So that is something, again, that you had to remember. By every time you use a tally, there might be some type of equation that you need to type in order to get the information that you need. For the cycle time, it's always the same. T now minus the attribute that you define for the arrival time. So next, we have the cycle time per part type. So there's 2 ways you can do this. As I mentioned last time, you can use a branch block. You can do something like this. And then add if part type equals 1, you're going to send that part through that branch. And then you can use an else for part type 2. So basically what you're doing is repeating the same branch that you have here to split the entities at the end of the simulation. And then you have a branch that you're going to add a tally to do the same thing. T now minus arrival time for part type 1, T now minus arrival time for part type 2. It's an easier way to do this. And what I'm going to do is just call this set. Instead of using this branch block, I'm just gonna call this other tally. The tally ID, see if I remember. We're gonna be using the CT by part type. So this is gonna be CT by part type. And inside that, will be the attribute that we use to differentiate. So this will be the set name, CT by part type, open parenthesis, and then the attribute that we use to differentiate the entities, which is going to be based on part types. And the value is the same, T now minus arrival time. I close this. And I connect this to. And then after that, then we have everything that we need. So I'm going to get the dispose block. And I'm going to save. Before I set up the experiments, I want to check that my model is good. There's no error. So I'm going to use this option right here, this check mark, to check my model. It looks like there's no errors. Can you check yours and let me know if you have any errors? Nope. Okay, so this is good. Now what we're doing is just setting up our experiment. So let's go to the Run tab and go to Setup. And in Setup, I'm going to go one by one, starting with run speed. This is for the animation, so we don't have to worry about this one. So we can go to the next one. This one is also okay. We don't have to worry about that one for now. For the reports, we need to select the Siman summary report, which is going to be printed using Notepad, and then click Apply. For project parameters, this is example 2. RS. And I'm going to uncheck all this because I don't want to get those statistics printed in my model, I want to only have those that I have created. And click apply. And then I move to the next one. Here, you say we want to run 10 experiments. We're gonna run this for 24 hours. So for the number of experiments, we're gonna change the number of replications to 10. We're gonna talk about the warm-up period later on in the class. So for now, we keep it as 0. And then for the replication length, it's gonna be for 24 hours, 24 hours per day. And our base time units are minutes. And then click apply. Click OK. And let's see if this runs. So let's run it. Okay, so this looks like a good report. What you're gonna see here is for each replication, you're gonna get a set of numbers, right? So for example, for replication 1 of 10, we get the cycle time 1, cycle time 2, minimum, maximum, and the number of observations. Drill utilization 0.52, 52%, and parts completed 306. When we look at the other statistics that for the output report, you can see that these are the same, right? Because this is an average. This thing is averaging the only one experiment, the results are gonna be identical. Then if we look at the next one, you'll see that's the same case. You're gonna get the report for the outputs for each replication, but what we are interested in is going at the bottom. Here's the output summary for the 10 replications. And as you can see here, this is the average across all experiments. So on average, the utilization of that drill 1 was about 60%. You get the half width and you get the minimum, the maximum for 10 replications. Same thing for cycle time, part type 2, cycle time part type 1, and the average parts completed. So that's the end of the exercise. Any questions? You guys got the same numbers? That's awesome.
I'm having issues having the file pulling up through the setup. Could you go over again?
Yes. So after you're done, you stop the simulation, right? And then go to setup. In the reports, you select the Siman.
So you get the same result using the branch look?
So that's a very good question. The answer is no. You get very close numbers, but they are not going to be identical because the way this operates is based on a random number generator that is creating all these probability, these numbers that are based on probability distributions. And the logic that you use alter the order these numbers are generated, right? The numbers are not going to be, they're going to be very, very close, but they're not going to be identical. Okay.
Could you pull up the report again?
Yes.
Sorry.
So if you go to the last report, these are the numbers. And that's okay. If you, for example, in the assignments, you don't necessarily have to match my logic. as long as what you're doing is correct. And maybe the numbers are not gonna be identical for my solution, but still, if your logic is correct, then the exercise is gonna be correct.
They're supposed to be relatively similar.
Yeah, it should be, I mean, even though you're using a different set of blocks or a different sequence, for example, you still get a number that is very close. Good. So I'm gonna stop the recording now so I can have both videos combined. And then I'll post